here what is this is reef first chapter first problem. Okay, what is the probability of throwing a total of 6 points or less with 3 dice? Okay, you have thrown 3 dice here. Okay, 1 2 3, so 3 dice are thrown. Okay, so dice 1, first one, second one, so third one. Okay, what is the probability of what you call so getting a point, 6 point or less? Okay, when you have thrown 3 dice. Okay, so you have thrown 3 dice together, you can take that idea. So in this kind of situation, look at here, what is the total number of possible outcome? You have to see that, am I right? So you can define, so probability of something A is equal to number of events favorable to A divided by total number of possible event. Am I right? That's how you are going to define the basic probability, isn't it? Total number of possible events. Now I need the total number of possible event in this situation. What is the total number? Can you quickly tell me? So total possible outcomes.
27.
No, I mean you have thrown 3 dice, isn't it? What is the total possible outcome?
Okay.
So each
216.
dice can have 6 what you call different outcome. Am I right? Again, you can take a principle of counting. Am I right? You have 3 dice. Okay, so one dice can have 6 possible way. So again, after that, second dice can have 6 possible way. For each of these two, third dice can have 6 possible way. Your principle of counting says 6 into 6 into 6. Is that okay? What is this one value? Quickly tell me.
216.
Sir, 216.
216. Okay, so that is the total number of possible outcome. Okay, among them, what is the number of favorable outcome? That means what is the probability of getting 6 points or less? Okay, number of outcomes in which all 3 dice together gives 6 point or less. This is what you call your numerator part. You need to find this one. Okay, let us find this one. To find this one, you better go for possible number of possibility here. Okay, you have 3 dice, you have thrown 3 dice here. Okay, let me start with minimum 1 1 1. Okay, all dice gives you 1 1 1. Okay, so this 1 1 1 can happen in only in one way. Is that okay? So again, first dice gives 1, second dice gives 1, third dice gives 1. This can happen in only one possible way. Okay, so again, this total is 3, which is less than 6. Okay, the total point is 3 here. Okay, so similarly, let me go for next higher one. You have to think possibilities here. Okay, what is the next higher one? 1 1 2. Am I right? This 1 1 2 can happen in 3 different ways, isn't it? 1 1 2 1 2 1 2 1 1. Am I right? First dice 1, second dice 1, third dice 2, first dice 1, second dice 2, third dice 1. Like that, there are 3 possible ways here. Okay, there are 3 possible ways of getting what is the total point here. So here total point is 3 here. Am I right? So here total point is so 2 plus 1 3 plus 1 4, like that. Okay, so again, total number of possible ways of getting 1 1 2, so that is 3, just like here 1 1 2 1 2 1 2 1, so 2 1 1. I hope you got this idea. So similarly, what is the next higher number? Can you speak out? What is the next higher number? 1 2 3. This has 6 possible way, remember. So 3 plus 2 5 plus 1 6. Okay, 6 point can happen, 6 point or less. So that is the question. Okay, 1 2 3 can happen, but 1 2 3 can happen in 6 different way. Okay, so now again, what is the total number of different way here, whatever you have counted? So that also can be what you call calculated using your what you call, it's a kind of permutation with repetition. Am I right? So here all 3 are same, isn't it? So total is 3. You have 3 again you have 3, all 3 are of same type. Am I right? So that will become 3 factorial divided by 3 factorial, isn't it? So that will become 1 here. So among these 3, so 2 are of one type. Am I right? Divided by 2 factorial into 1 factorial. Is that okay? So that again, this is 3 factorial divided by 3 factorial into 0 factorial, that's equal to 1. This is 3 factorial divided by 2 factorial into 1 factorial, so that's equal to 3 here. So similarly here 3 factorial, all 3 are different, am I right? So that means 3 factorial is the number of permutation here, okay? Whatever I am writing here as a index, these are number of permutations, okay? I hope you got this point. Anyone? Any question? Quickly. So number of permutation of getting 1 1 1, that's 1. Number of permutations of 1 1 2, that is 3, okay? Because among all 3, 2 are of one type, other is other type, isn't it? Among all three are different. That's why number of permutation of getting 1 2 3, okay? That is 6 here. So similarly, collect all possibility, okay? 1 2 3. What about 1 1 1 1 2 2? This can also happen. 4 plus 1, isn't it? So this can have again 3 possible way, because out of 3, 2 are of one type, okay? So this will have 3 what you call permutation, okay? So similarly, anything that I left here, speak up.
Sir,
1
113.
1 1 3 1 1 3. So this also have 3 ways. Anything else quickly? Speak up.
So 411.
4 1 1 1 1 4. This also have 3, because so among these 3 again whatever this index I am writing, these are number of permutation. Now count all of these permutations. I think this is over, am I right? 114 113 122 123 112 111, isn't it?
Sir, 222.
222 can happen.
Sir, 222.
Yeah, 222. This can happen in only one possible way, okay? The number of permutation of getting 222, that's equal to 1 actually. Can you count the total number of permutation? That is nothing but number of outcomes here. So can you count here? So 10, 20, is that okay? 6 plus 3 plus 1, 10, 3 plus 3 plus 3, 9 plus 1, 10, total 20. So these are the only possibility, okay, of getting 6 point or less. Here you are getting 6 point, here you are getting 6 point, here you are getting 5 point, isn't it? Here you are getting 5 point, here you are getting 1 2 3 6 point, isn't it? Here you are getting 2 plus 2 4, isn't it? Here you are getting 3 points, okay? So again, probability of getting 6 point or less, again number of outcomes in which 6 point or less, that is equal to 20. I hope you got the idea. So that's why the required probability that he is asking, what is the probability of throwing total 6 point or less? Probability of throwing 6 point or less when you have thrown 3 dice together, that's equal to 20, that's a favorable, divided by 216, okay? So there will be this kind of question where you need to work out the possibility, okay? You can't apply what you call direct any formula or something. You need to work out this possibility, okay? While working out this possibility, don't leave anything. Can you have any better way to arrange this one? You better to start with this one, am I right? So the total number 111, okay? That's equal to 3, am I right? So next higher number is 4, am I right? What is the possible way of getting 4 here? That's the best way to what you call remember, am I right? 1 1 2, isn't it? So 5 1 2 3. So that but 5 can happen in 1 1 3 also, isn't it? 5 can happen in 1 1 2 also. Okay, so again 3 4 5, and next one is highest one is 6. Okay, 6 can happen in 2 2 2 and 1 1 4, isn't it? In a two different way. This is the best way, okay? So try to order this one in an increasing manner. I hope you will not miss anything. I think 1 2 3 is not this is 6, am I right? 1 2 3 6 actually here. So try to make this in one order here, okay? 1 1 3 1 1 3 1 2 2, that's equal to 5, okay? What else you will get 5? So these two will give 5 actually. 2 2 2 1 1 4 and 1 2 3, these three so together will give 6 actually, okay? You have to order like this. I hope you will not miss anything, isn't it? You can think what are the other possible way of getting 5. So 3 integers, again those integers individual integers should be less than 6, isn't it? You can think like that, okay? So I hope you can deal with this kind of question where you need to collect possible outcomes, and you will get to know again. So this the total number of outcome is quite easy, okay? So get ready for this kind of question. I'll go to one more binomial distribution problem. Again, random walk problem depends on binomial distribution, isn't it? A random number generator outputs plus 1 or minus 1. Okay, output is either plus 1 or minus 1. Okay, with equal probability. Okay, so probability of getting plus 1, that's equal to half. Probability of getting minus 1, that's equal to, let me write it as q. Okay, so probability of getting plus 1, I'm writing it as p. Probability of getting minus 1, let me so make the notation better. Okay, so probability of getting plus 1, I'll write it as p, or I'll write it as or whatever, that's equal to half. Probability of getting minus 1, that's equal to q, I'll call it as q, that's also equal to half. Okay, he said with equal probability. Okay, every time it runs. A random number generator outputs plus 1 or minus 1 with equal probability every time it runs. Okay, after it runs 6 times, what is the probability that sum of the answers generated is 0? This is the question. Okay, now look at here, this is exactly binomial distribution problem. First let me define what is the binomial distribution. Am I right? Binomial distribution, as the word says, binomial. Am I right? Again, bi, isn't it? Again, when there is a occurrence or non-occurrence. Okay, when there is a what you call success or failure, when there is only two possibility, so we can apply binomial, isn't it? So here also there are two possibility, we can apply binomial distribution. Okay, so now again look at here, we say again, so probability after n trial, n1 success. Okay, we say we have done n trials here. So suppose among those n trial, n1 are succeeded. Okay, n2 are failure. Okay, so again, so there are only two possibility. Again, one is possibility of success, other is possibility of failure. Okay, in that case, again, n1 plus n2 is equal to n. Okay, we can define, again, suppose probability of success, I'm going to define it as p. Probability of failure, I'm going to define it as q here. So in this situation, look at here, probability after n trial, n1 success. Okay, probability after n trial, n1 success, that's equal to ncn1. Okay, p raised to n1, probability of success raised to n1, q raised to n2. Again, number of failures. Okay, or we can write it like this, ncn1 p raised to n1 q raised to n minus n1, isn't it? Using this one, n2 can be written as n minus n1. Okay, I hope you can just recall this binomial distribution formula. Okay, so now let me just apply this binomial distribution formula here. Here let me take plus 1 is success, minus 1 is failure. You can take like that. Okay, you have only two possibilities here. Okay, so now in this situation, again, so can I about this part? I hope you can recall your binomial distribution quickly using I think you can go through Gravel or any textbook. Okay, basic binomial distribution. When there is occurrence or non-occurrence, or when there is only two possible ways of again occurrence. Okay, when there is two possible outcome, we can apply binomial distribution. Okay, now let me take one is success, other is failure. You can take like that. Okay, so probability after 6 time run. Okay, after 6 run, probability of getting 0. Am I right? So when you have 6 run, so definitely you had 6 output. Am I right? Among those 6 output, look at here, if 3 outputs are plus 1 and 3 outputs are minus 1. Okay, among these 6 output, if 3 outputs are plus 1 and 3 outputs are minus 1, so then the net answer is 0. Am I right? So you will have plus 1, so plus 1 plus 1 plus 1, minus 1 minus 1 minus 1, or plus 1 minus 1 plus 1 minus 1 alternatively, so that if you have 3 plus 1 and 3 minus 1, so total number, again, so the sum of the answer, the sum of the, so total number generated, that's equal to 0, isn't it? Now, so now look at here, probability after 6 run of getting 3 success. So let me say this one as success. Okay, okay, or again, so let me take probability after 6 run. Okay, 3 plus 1, probability of getting 3 plus 1 after you run that number generator 6 times. Okay, so if 3 times, if you are getting 3 times plus 1 means other 3 times, again the inbuilt meaning is other 3 times you are getting minus 1. So that's why this can be written as, look at here, 6c3. Okay, So probability of getting 3 plus 1, am I right? That's what I defined. So 3 plus 1, okay? That means probability of getting 3 plus 1, this one probability of getting exactly 3 plus 1, okay? Exactly 3 plus 1 means, again, probability of getting 3 plus 1 and 3 minus 1, because you are talking about 6 outcomes here, okay? 6C3, you can write probability of getting plus 1, that is equal to half raised to 3, and probability of getting minus 1, that's also half raised to 6 minus 3. 6 minus 3 is 3 again. What is this value? Can you quickly tell me? 6 factorial divided by 3 factorial into 1 by 8 into 1 by 8. Can I write like this? 6 into 5 into 4 into 3 factorial, 3 factorial, 3 factorial, 1 by 8 into 1 by 8, isn't it? I think one of the 3 factorial can be cancelled. This 3 factorial I can write as 3 into 2, 2 on the 2, 3 the 6, 3, 3 got cancelled, 4 1 the 4 2 the, isn't it? 5 by 16,
Yes.
is that okay? 5 by 16, okay? So I hope these kind of problems we can handle, isn't it? Again, application of binomial distribution, okay? Option C, this is a old not just question, this is a old TIFR question, okay? Yeah. So shall I move on? Probability after n trial, n1 success, that's equal to nc n1, probability of success raised to n1, probability of failure raised to n minus n1. Remember, p plus q should be equal to 1, okay? Here he said equal probability, that's why half and half. I hope you can deal with this kind of problem.
Yes.
This binomial distribution not only helpful for only that problem, okay? Again, that is helpful for some other problem also. Let me try to handle this problem, the reef problem, okay? First chapter, second problem. This can also be handled using what you call your binomial distribution, because whenever there is a whenever you are talking about occurrence and non-occurrence, you can definitely use binomial distribution, okay? Consider a game in which 6 true dice are rolled, okay? 6 dice are rolled. Find the probability of getting exactly one ace, at least one ace, exactly two ace. Look at here. He's talking about occurrence of ace or non-ace, isn't it? Are you getting my point? Occurrence of ace or non-ace. Exactly one ace, at least one ace, exactly two aces, like that. So this problem also contains occurrence and non-occurrence. Two possibility. That's why we can apply binomial distribution. So that's why, look at here, but we need to modify this problem. The modification is like this. What he has done is he has rolled 6 dice together, isn't it? But in case of our binomial distribution, what we do, we do the n trial. Among those n trial, we take n1 success, isn't it? Again, that's how we define, okay? You can define in a different way also. That's how we define. Among n trial, n1 success, okay? That's how you define in case of binomial distribution. N1 success, n2 failure, like that, isn't it? So now look at here. What I do here is, since I'm throwing 6 dice together, what I do here is, let me make one statement. Just observe that one. Okay, throwing 6 dice together once is equivalent to throwing one dice 6 times. Can I write like this quickly?
Yes.
Throwing 6 dice together once, that's equal to throwing 6 dice. So throwing one dice 6 times, isn't it? And again, whatever the probability you discuss here, the same probability you can discuss here also, isn't it? Now let me convert this problem to binomial distribution problem, because quite easy to work out actually. You don't have to work out all possibility like that. Those are quite lengthy. Is that okay? So that's why let me take this problem, throwing one dice but 6 times. Okay, you are throwing one dice again 6 times. Okay, what is the probability of, again after throwing 6 times? Okay, what is the probability of getting one ace, at least one ace? Again, so exactly two aces, like that. Now look at here. So each of these, again he is talking about, again, getting ace or not getting ace. Am I right? Ace means you can take it as 1. Okay, I don't know what exactly Ace he is talking about in case of dice actually. Let me take ace means number 1, okay? In case of your dice, you will have 1 point here, isn't it? So let me take that one as ace, okay? Whatever, it doesn't matter. If you take that ace equal to 2, then also the same thing will happen, okay? Now look at here. So getting ace, not getting ace, am I right? We are talking about this one. So that's why what I do here is I'm throwing one die 6 times, okay? So each of the time when you throw, you have two possibility. You have probability of getting ace, okay? So that let me call that one as P. Let me call that one as success, okay? That's equal to, so can me this 1/6. Is that okay? If you throw one dice, okay? I'm talking about one dice. Later I'm going to throw that one 6 times. I'll get what is the required probability there. Okay, probability of getting ace when you throw one dice one time, that's equal to 1/6. Can I write like this? So similarly, probability of getting not getting ace, what is this one? Speak out. Let me call that as failure.
5/6.
5/6. Am I right? Probability of not getting ace means, again, suppose if a is equal to 1, I mean I'm asking about probability of getting 2, 3, 4, 5, 6. Am I right? That's equal to 5/6. Is that okay? So now let me call this one as P, other one as Q. Now after 6 trials, okay, after 6 throw, after 6 what you call trials, okay, what is the probability of getting exactly one ace? Okay, what the probability of getting exactly one is, that's equal to 6C1 probability of getting is raised to 1, probability of not getting is failure raised to 1 minus, sorry, 6 minus 1. Am I right? So can I write like this? Look at here how simple it is. 6 factorial divided by again 5 factorial into 1 factorial, so 1/6 into 5/6 raised to 5. So can I write like this quickly? So tell me,
Yes, sir.
is that okay? So look at here, out of n trial, okay, n1 success, only n1 success, exactly n1 success. That is the meaning of this one. So that's what he's asking. Out of 6 what you call, so trial, exactly one is. So that's what I have calculated here. Is that okay? Out of 6 trial, getting 1 ace, that's equal to 6C1. Look at here how I am reading this one. Okay, probability of getting ace raised to 1, probability of not getting ace raised to the rest of the power. Okay, n minus n1. So can I write like this? Probability after n trial, n1 success, that's equal to nc n1. Okay, so here probability of success raised to n1, probability of failure raised to n minus n1. So can I write like this? That's the best way to remember, isn't it? Probability after n trial, n1 success. nc n1, probability of success raised to n1, probability of failure raised to n minus n1. Okay. So now again, this is the part A of the problem that is done. You just calculate this one and match up with the answer. Okay. This is the reef question. I hope you can see this one. First chapter, second question. Okay. Part B of the question. What is the probability of getting at least one ace? Okay. Probability of getting at least one ace. Again, what do you mean by this one? This means probability out of 6 trial, okay, getting 1 ace plus probability out of 6 trial getting 2 ace, isn't it? At least 1 ace means minimum number is 1, am I right? After you throw that one 6 times, 2 times also ace can happen, 3 times also ace can happen, am I right? Probability of at least 1 ace means probability after 6 throw, probability of getting 1 ace plus probability of getting 2 ace plus probability of getting 3 ace plus probability of getting 4 ace plus probability of getting 5 ace, isn't it? Plus probability of getting 6 ace, isn't it? After 6 trial. Now what is missing here? What is missing here? What I do here is I am going to add probability of getting 0 ace after 6 trial and I'm going to subtract. Look at here, this is the required probability. At least one S means getting one S or getting two S or getting three S, four S, five S or six S. Okay, what I do here is for this required probability I'm going to add this one and I'm going to subtract this one. Is that okay? This is probability of getting 0 S. Now what is this total? Can you just tell me what is this total? Speak up.
1
Why?
total problem.
That's the
So
total possibility, am I right? Either you should get 0 S, 1 S, 2 S, 3 S, or again and so on or up to 6 S, am I right? That's why this can be written as 1, because look at here, in this binomial distribution n1, okay, if you take summation over n1, okay, if you take all possible n1, that should be equal to 1. That's actually equal to p plus, do you remember this one? This is how binomial the word came, am I right? P plus q raised to n actually. These are the binomial coefficients actually. I mean the binomial terms actually. P n of n1, whatever we write. Okay. Now look at here. This is 1 minus p6 of 0, isn't it? Because this is easy to find. These are all quite difficult to find. Am I right? So together we have to add. That's why this is easy. That's why this is equal to 1 minus, what is this one? 6c0 into p raised to 0 q raised to 6. Am I right? 6c0 means, speak out. 6
1
factorial divided by 6 factorial, 0 factorial, that's equal to 1. This is 1 by 6 raised to 0, 5 by 6 raised to 6. You can just find out this one. So can you find this one later? The value. Is that clear? This problem can be done in a different way because this may be helpful for some other question. Okay, probability of getting at least one S plus probability of getting no S. What is this one? Can you quickly tell me? Probability of getting at least one S plus probability of getting no S. Speak up. Speak up.
1.
1, isn't it? Because you should get at least one S or you should get no S, isn't it? You should get either 1, 2, 3 or 6 S's, okay? Or you should get no S, isn't it? That's why this should be equal to 1. That's why probability of getting at least one S, this can be written as 1 minus probability of getting no S. Can I write like this? Now you know this one. 1 minus after 6 trial 0 is, you can quickly substitute this also. Okay, I mean this is a logical step actually. If you have good logical thinking, you can apply like that. Is that clear? Quickly reply.
Yes. Or we can
No.
directly write 5 by 6 to the power 6.
Yes, speak
Probability
up.
of getting no S, we can direct probability of getting no S.
Yeah, you can directly write 5 by 6 raised to 6, am I
Over
right? Because this will become 1.
6, yes.
Yeah, that's also okay.
Yes.
Yeah. So part C of the question, after 6 trial, okay, what is the part C of the question? Exactly 2 S's, isn't it? Exactly 2 S's. That means, so that's equal to 6C2, 1 by 6 raised to 2, 5 by 6 raised to 6 minus 2, that is 4. Okay, you can evaluate this one. Okay, I mean this is a reef problem. I think in exam, I think they will provide you calculator, isn't it? In case of just exam, I think scientific calculator is allowed, isn't it? You can do that one. Okay, any squaring, whatever you have, you can do this one. Yeah, any question here? Application of binomial distribution. Even though the problem doesn't seems to be binomial distribution application, if there is occurrence and non-occurrence, you can apply. Definitely you can apply. Okay, you should apply because that is the easiest way. Okay, so let me proceed. A drunk starts from the lamp post. Okay, a drunk starts out from the lamp post in the middle of street, taking a step of equal length equal length either to the right or the left with equal probability. Okay, we have seen this problem already, isn't it? So this is the lamp post, again equal length to the right or left. Equal length, so to the, so equal what you call length. Okay, each steps of equal length. Okay, either to the right or left with equal probability. Can I write P is equal to Q is equal to half here? Okay, quickly probability of getting step to the right, probability of taking step to the left here. Okay, what is the probability that man will again be at the lamp post after taking n step? Okay, after n step, okay, after n step, if n is even, look at here, he has given n is even. So after taking n step, if n1 is equal to n2, let me take n1 step to the right, n2 step to the left, am I right? n1 step to the right, n2 step to the left. Okay, if n1 is equal to n2, if n1 is equal to n2, again your x will be, look at here, m into l. Do you remember l is the length of the each one? M is nothing but difference of n1 and n2. If there is no difference of n1 and n2, isn't it? n2 minus n1 into l, am I right? If this is 0, this will be 0. That means he will come back at the same point. If number of step to the right equal to number of step to the left, okay, he will come back to the same point, isn't it? That is the basic idea. Now look at here. Again, if n is even, if total number of step is even, what is the what is the probability after taking n step? Probability after taking n step, okay, n1 step to the right, which is equal to n2 or equal to n by 2. Can I write like this? N is even. Now this is integer. Is that okay? Because n1 plus n2 is equal to n. If n1 is equal to n2, 2n1 is equal to n, n1 is equal to n by 2. Okay? So can I write like this? Probability after n step, half of the step to the right, other half to the left, so that he will come back at the origin. That's what he is asking. What is the probability that a man will again at the lamp post after taking n step if n is even? Okay? So now this is equal to n c n by 2. So half raised to n by 2, half raised to n minus n by 2, that's n by 2 again. Isn't it? This is equal to n factorial divided by n by 2 factorial into n by 2 factorial, n by 2 factorial square. Can I write like this? Or n by 2 factorial. So half raised to n, can I write like this? N by 2 plus n by 2. This is the option. Is that okay? Speak out. Very simple.
Yes, sir.
Now look
Yes.
at the next question. You don't have to even think, isn't it? If you have this logic. In the previous problem, okay? So he has taken n step, okay? What is the probability? What is the probability that the man will again be at the lamp post after taking n step if n is odd? So can you quickly tell me?
0.
Don't go for
0.
defining them. You will end up with a odd integer or something, factorial of them. Okay, this is 0. Why? If n is odd, so there is no possible way of getting number of step to the right equal to number of step to the left. Am I right? Isn't it? If n is odd, you can't divide this one into two integers, isn't it? You can't divide exactly half of other one integer, half of other integer. That's why obviously if n is odd, there will be a net displacement. There is no possibility of getting back to the what you call lamp post again or origin again. That's why this probability is 0. Okay, don't go for defining this one because this would be meaningless. Why? You will get some half integer what you call or some fraction power or what you call factorial or something. Okay, just avoid this step. Okay, I hope you can deal with this question. Not a big deal. Yeah. So two drunks problem. Okay. Two drunks start out together at the origin, each having equal probability of making the step to the left or right along x-axis. Okay, two drunks are there. Okay, two drunks are there. Somehow they are not colliding. Okay, just think like that. That's why I have drawn the separate track here. Okay, let me give the separate track for each of them. These are the step lengths, okay, whatever I have drawn. Okay, there are two drunks, each of them are taking n step. Okay, he is also taking n step randomly either to the right or left. He is also taking n step, total n step, okay, either to the right or left. Is that okay? So two drunks start together, they start together, okay, at the origin, each having, so this is origin, okay, this is 0, origin here, this is x-axis, you can think like that, okay. This is origin, okay. Now look at here, find the probability that they meet again after n step, okay. I mean, each of them have taken n step, I think, isn't it? Two ducks talks together at the origin having equal probability of making step to the left or right along x-axis. Find the probability that they meet again after n step. Okay, I mean, after n step means not total number of step is n. Okay, each of them are taking n step. Okay, each of them are taking step together. So then, if n step happens together, okay, that means he is taking n step, he is taking n step. That is the meaning. Okay, each of them are taking step together, and total number of step is n step. That means individually they are taking n step and n step. Okay, that is the basic idea. It is to be understood that men make their steps simultaneously. Okay, so then the probability that an event characterized P occur, and again I'm not getting what. Oh yeah, so he's asking this probability. Find the probability that they meet again after n step. Okay, so that probability you need to find. So in Reef he followed one step actually. That is a kind of trinomial kind of distribution. Okay, so what can happen here is, again, when they take each step, they can either move together, they can either move apart, or they can maintain a constant distance. Am I right? Three things can happen. Okay, he defined P, Q, R. Okay, so probability that they go away from each other when they take one step simultaneously, probability that they move each other when they take simultaneous step, okay, probability that they maintain a constant distance. Okay, he's going to define this one, and he's going to take a trinomial distribution P plus Q plus R whole power n like that, but that is too lengthy. Okay, so again, in the last discussion, one of our student gave the idea. Look at here, this is equivalent to, okay, fixing one person, okay, fixing one person, okay, fixing one person at origin, so other person takes a 2n number of steps. Okay, he's at the origin only, this person will be at rest. Okay, again, this is a kind of frame of reference kind of question. Look at here, I'm getting it, this is person A, person B. Okay, I'm going to the frame of reference of person A, and I'm going to observe the whole event. If I go to frame of reference of person A, with respect to him, B is moving, am I right? And with respect to him, B is taking 2n number of steps, because he also take n step, he also take n step. So again, if you go to this person frame of reference, total number of step, again, if you go to that, if you take that one as rest frame of reference, okay, you will feel that, so the person B, okay, so in the frame of reference of person A, person B will take 2 steps together. Can I say like this? He will take 2 steps. So after n step, he will take total n number of steps. So total n step. So after n step, so the total number of step he is going to take, the person B take. So look at it. This is in the rest frame of A. In the rest frame of A. Okay. So again, if he takes 2 steps, so what we are doing is, we are fixing our what you call reference frame at A. We are observing whole events. Then with respect to A, look at here, B will take 2 steps, okay, either to the right or left in the with a very equal probability, very random. Okay, so that's why total number of steps that B takes, that will be 2n. He takes 0 steps, he takes 2n number of steps. These are equivalent. Can you feel this one or not? Quickly reply. Is that okay?
Yes, sir.
Both of them taking steps simultaneously, that is equivalent to one of them is at rest, other is taking 2 steps. So the total number of steps that is take 2n. Is that okay? And again, each of the steps are random. That's why P equal to Q is equal to 1 by 2 for him. Is that okay? Now again, this probability, find the probability that they meet again. that is equal to what is the probability that he come back to the origin. When he come back to the origin, that means they meet again. Am I right? Are you getting my point? What is the probability of that they are meeting again? That means what is the probability that this person B who has done total 2n number of steps, what the probability that he comes back to the origin? Look at here, 2n is always even. Am I right? Are you getting my point? There is a probability that he will come back to the origin. Are you getting my point? 2n is even, it's not odd, am I right? If it is odd, then he would not have come back to the origin, isn't it? 2n is always even, whatever n value here, whatever n integer here, okay? So this automatically happens. So now that required probability that they meet again, that's equal to, look at here, probability after 2n step, okay? Probability after 2n step, okay, B, I'm just concentrating on B here, A is at rest here. So n step to the right, n step to the left, can I say like this? Among 2n, okay, n1 to the right, that's equal to n, n2 to the left, that's equal to n. Half of the step to the right, half of the step to the left, then obviously the net displacement will be 0, he will come back to the origin again. Are you getting this point? Quickly, someone reply. That's equal to 2n
Yes.
Cn, okay, p raised to n, q raised to n minus, so 2n minus n actually, 2n minus n, 2n minus n. So can I write like this? After 2n step, n1 step to the right, that's equal to half of this one. Are you getting this point? Quickly.
Yes.
Yeah. So this is equal to 2n factorial divided by n factorial, n factorial. This is half, am I right? This is half and half. Yeah, he said equal
Yes, sir.
probability. Again, so he's also taking equal, probability that B takes step to the right or left, that is completely random, okay? So that's why half power n into half power n, half power 2n, am I right? 2n factorial divided by n factorial square half power 2n. So can I write like this? Let me check out the answer. I mean, it is there. 1 by 2 raised to 2n, 2n factorial divided by n factorial whole square. That's correct. Okay. Now we shall try to answer this question.
Sir,
Yeah, tell me.
sir, in that question, in the original problem, if A and B makes one step in the same direction, so that the relative displacement is zero, right? So in that second case, there is also probability that B is not taking any step, isn't it?
No. Again, they are taking steps simultaneously. Look at here. If he also moves like that, then they are maintaining what you call they are there only, isn't it? Are you getting my point?
Ah, yes, sir.
That
So
means, look at here, if suppose he is also moving like this, he is also moving like this, that means that is equivalent. He is at rest, he has taken two steps, one step to the right, other step to the left actually. You can think like that, am I right? So that he come back to that,
okay.
isn't it? So that's why these two are equal. You can find equivalent thing here actually.
Okay, sir.
Yeah. Now again, can you answer this one? I think this one you can answer. Both are same. So this is old JEST question, I think. Can you quickly answer this one using this idea? A trunk starts off together at the origin, each having equal probability of making steps simultaneously to the left or right along x-axis. The probability that they meet again after n steps is equal to 2n factorial n factorial whole square 1 by 2 power 2n 1 by 2 power 2n 1 by 4. So can I write like this? This one?
Yes, sir.
But this bracket should be there here, okay? Are you getting my point? In the first option, bracket should be there. Yeah. So that's equal to 1 by 4, again 1 by 4 power n, 2n bracket factorial divided by n factorial bracket whole square. That's the best idea. Okay. So n is the total, small n is the total number of steps. That's what he has given. Okay, you can choose the option. Okay, so similar question is there here. I think you can solve it. Not a big deal. Okay, so shall I move on to next question? So permutation with repetition. Okay, I think I have solved this one in class. Let me briefly give the idea here. Okay, the elasticity of a rubber band can be described in terms of one-dimensional model of polymer. Okay, one-dimensional model of polymer involving n molecules. Okay, so total number of molecules is n here. Okay, n molecules linked together end to end. The angle between successive link is equally likely to be 0 degree or 180 degree. You can say each of this link, as he has drawn the diagram. Okay, each of these link that can be either like this or like this. Okay, just say a molecule will have tail and head. Okay, you can say like that, isn't it? If you take any molecule, it will have a tail and it will have a head, isn't it? Okay, you can think like that. Okay, so if that molecule align like this, suppose if you take this one as x-axis, so that means it is aligned 0 degree. Okay, if molecule is aligned like this, you can take it is aligned 180 degree to x-axis. You can think like that. Okay, so but he is talking about angle between successive link. He is so talking about relative angle. So let me talk about that. Okay, now he is saying so there are n molecules like that. Total length is 2md. Okay, total length is equal to 2m into d, where d is the length of the each link. Okay, that's what he has given. So now look at here, it's exactly similar to our random walk problem. So because again, suppose if you start here, first link can arrange like this, second link can arrange like this. That means that can be either 0 degree or 180 degree. Okay, third link can be again 0 degree to the what you call second link. Like that it can happen. So that again, so let me take one idea. Suppose there are three links. Okay, first link can be like this, second link can be 0 degree to first link. Okay, second link will be attached to the what you call head of the what you call the tail of the second link, so that will be attached to head of the first link actually. Okay, so this is how it will happen. The third link can be 180 degree like this. Okay, the third link that can be 180 degree, so this can happen. Okay, so that's why what will decide the length. So here the length is very much similar to whatever the total displacement whatever we have in case of our random walk problem. In case of our random walk problem, do you remember anyone? X is equal to, we are going to write m into L, where L is the length of each length. Can you hear me?
Yes, yes.
Is that okay? Where L is the length of each each step, isn't it? So similarly here D is the length of each link here. That is the only difference. And we have written that M is equal to N2 minus N1. Am I right? Number of step to the right, number of step to the left. Again, the difference will give you the the difference is an integer. That integer multiplied with length, that will give you the displacement. Am I right? So exactly the similar formula should be applied here. He has given L is equal to 2m into d. Let me take look at here. N1 number of link they are aligned 0 degree. N2 number of link that are aligned 180 degree. Is that okay? So again, so that N1 plus N2 is equal to N. Among N molecules, N1 molecules align 0 degree, N2 molecules align 180 degree, so that this 2m will be given by, again look at here, he gave one confusion factor. Here we take m, am I right? M is the usual symbol we take in in case of reef book or something, isn't it? But he gave 2m here, that this 2m, okay, this multiplicative factor, that should be equal to n2 minus n1. Again, it all depends, okay, but so try to make it positive, because the length should be always positive quantity, isn't it? So I'll take 2m is equal to n2 minus n1 and n is equal to n2 plus n1. Okay, from these two equations, can you solve it for n1 and n2? When you add these two equations, what would happen? 2m plus n is equal to 2n1. That means n1 is equal to speak out anyone? 2m plus n whole divided by 2. So similarly, you can
So 2
subtract.
N2.
Yes, speak out.
2 N2.
No, I have
10
added
plus
these
n
two.
is equal to.
Okay. N2 minus N1, am I right? N1 got
Yes, 2
cancelled.
N2.
Yeah, N1 got cancelled when I add these two. So what will happen? 2N2 is equal to 2m plus n, okay, n2 is equal to, let me write n plus 2m whole divided by 2. So similarly, you can solve it for n1. I hope it will be n minus 2m. Okay, you have to subtract these two, isn't it? N minus 2m whole divided by 2. Am I right or not? You can solve it for n1 and n2.
Yes, sir.
Now, so number of possible ways of getting n1 linked with 0 degree, n2 linked with 180 degree. This is nothing but our permutation with repetition actually. Is that okay? So out of n, okay, n1 are of one type, n2 are of other type. Am I right? So this is the total number of possible way for permuting them. Okay. So total number of permutation of n object, out of which n1 are of one type, n2 are of other type. This can be given by this ratio, isn't it? In this possible situation, look at here. So this will be n factorial divided by, what is n1 here? So can I write n by 2 plus m factorial? I'll divide by 2 individually. N by 2 minus m factorial. So can I write like this? But it is not over, okay? It is not over. The problem is not over. Look at here. Actually, the length should be written like this. Again, in place of this 2m, suppose if suppose n1 links are 180 degree, n2 links are 0 degree, so then also the next displacement is same actually. Okay, so because net length can be either, again, so here, so in the exactly in the same manner, in case of random walk problem, you can have net positive displacement or net negative displacement, am I right? But here we are talking about length, so that is not what you call, so that can be either, again, this 2m or this one, that can be either positive or negative, isn't it? So then also again length can be same, whether net displacement to the positive x-axis from the origin or net displacement is so towards negative x-axis from the origin, the length would be same, isn't it? That's why if n1 links make 180 degree, so out of n, if n2 links make 0 degree, so then also look at here, n2 minus n1, in that case that may be, so negative of earlier, that value may be negative of earlier, but length will be same actually. So that's why, so there are again, so there are exactly the similar number of possible ways. Can I write that number of possible ways as omega? So there are exactly similar number of possible ways, n factorial divided by n1 factorial, n2 factorial. That means n factorial divided by n by 2 plus m factorial n by 2 minus m factorial. Okay, so again there are exactly the similar possible ways of getting the same length actually. Okay, that's why you need to add these two together. You need to again, so to get total number of possible ways, so total number of possible ways you need to add together, that will be 2 times n factorial divided by n by 2 plus m factorial n by 2 minus m factorial. So that's what he was asking us to prove actually here. Okay, show that number of arrangement that gives overall length L is equal to 2md is given by this one. This factor 2 is because we are talking about length, we are not talking about any displacement, positive displacement or exactly positive or exactly negative displacement like that. Okay, since length is always so taken to be positive, it doesn't matter whether n1 links are arranged 0 degree, n2 links arranged 180 degree, or n1 links arranged 180 degree, n2 links arranged 0 degree. These two gives the same length actually, because this difference between these two will decide the net displacement. I hope you got these points, whatever I am trying to explain. Okay, so shall I move on? Any question?
Sir,
Yes.
sir, why don't we apply the same thing to random walk problem? Like they are
No,
also
again,
moving.
in case of random walk problem, we said that we have started from x equal to 0. Okay, we are moving along positive x-axis or negative x-axis. We said x equal to m into L. Am I right? Here, x is sensitive to what you call sign here, isn't it? Suppose x is equal to plus 5 means, again, you are somewhere here. X is equal to minus 5 means you are somewhere here. Am I right? Those are different. You have taken them as different actually. But in this case, whether positive displacement, net displacement, or negative net displacement, you said length of the link same, isn't it?
Yes, sir.
That's why the factor 2 should come. Be careful about that factor, because if they give the option, they may what you call manipulate the options, isn't it? Be careful regarding. So these are just look at it. This kind of question is there in JEST exam. Even a kind of numerical question is there. Okay, in JEST exam, there is a one-dimensional lattice with a lattice constant A, as shown. Okay, an atom transits from a site to a nearest neighbor site in every 2 seconds. Okay, in every 2 seconds, it's going to take a what you call one step. Okay, and probabilities of transiting to the right and left are P and Q. Okay, P is probability of transiting to the right. Okay, Q is probability of transiting to the left. Okay, that he defined here. Okay, now what is the average position? Again, what is the average position of the atom at the time t is equal to n into tau? Okay, at the time t, again n is very greater. At the time t is equal to n into tau, what is the total number of steps it has taken? That is n. Am I right? Are you getting it? We need only this information. Quickly tell me. He has given what is the average position after some time. After that time, how much step it has taken to apply our binomial distribution or random walk idea? You need the number of steps it has taken. Am I right? After this time, it has taken n number of steps. That's what you need here. Okay, so maybe question may be quite confusing when you read that one, but again, what is the required factor for us? The required factor for us is actually what is the total number of steps it has taken to find the average value. Am I right? What is x average? What is x equal to m into L? L is a here. Okay, each step of length a here, m into a here. Okay, m can be written as n2 minus n1 into a here. Okay, x average is equal to n2 average minus n1 average into a. n2 average is equal to, can you just tell me?
N into P.
N into P. I have to define, am I right? What is n1?
Yes.
So there are n1 step to the right, n2 step to the left. Let me take like that. Is that okay? n2 is nothing but n into q then, am I right? Can I write like this? n2 mean is equal to total number of step into that particular probability. n1 mean is equal to total number of into so that particular probability. nq minus, again you can interchange this one also. Okay, I mean in the option I don't think again so there are confusion p minus q or q minus p. Okay, or you can take n1 minus n2, suppose if you are worried about that one. Okay, but look at here, there are no option like na what you call p minus q as well as na q minus p. Okay, there is no confusion in that one, because sometimes you can take n1 minus n2, sometimes you can take n2 minus n1. Am I right? That's why, suppose if you are worried, let me take n1 minus n2. Is that okay? So x is equal to capital N into p minus capital, again average, wait a second, we need to take average. Am I right? Average is equal to n1 mean minus n2 mean multiplied with a, that's equal to n into p minus n into q multiplied with a. I hope you can deal with this one. Am I right? n p minus q into a. You have only one option. There is no what you call confusion in the option. Okay. Now next one is, in the previous problem, calculate the mean square value. This one, x minus x bar the whole square. Am I right? What is x minus x bar? Can I write it as delta x square the mean? This is a variance. Am I right? Variance in x. Can I say like this? X minus x bar means mean deviation, square the mean, isn't it? Is that okay? After n step again. What is this one? Anybody remember this one? As I remember, this is equal to 4 times npq into distance square, because this should be of the order of distance square. You can go for dimensional thing. Okay? A square. I think we derived this one in class.
Yes, sir.
He has given pq as it is. Okay? 4 npq a square. 4n pq a square. Is that okay? That's what you can say. Now look at here, there is one numerical problem on this one, exactly this one. Okay, in case of JEST exam. Okay, so try to solve that one. I think they have given these things in second or microsecond or something, so that you have to find total number by dividing or something. Okay, I hope you can deal with that kind of